Okay, in this video we're going to talk about how to solve a linear equation. So let me just write an example on the board and then we'll talk about what exactly do we mean by linear equations. So a linear equation is something that looks like this. A number times a variable plus a number equals 0 or equals something similar. And the main thing that's telling me that this is a linear equation is on both sides I never see anything other than x to the first power. So there's no x squared, which would make it quadratic. There's no other functions acting on x. It's just x's and numbers multiplied and added up. And the biggest power of x that I see is just x to the first power. So that's what makes an equation linear. This is kind of the simplest example of a linear equation I could get. Okay, so our goal is to end up with x is equal to something. Right now this is telling me that 2 times some unknown x plus 1 equals 0. So that's telling me certain values of x would make this statement true, certain values of x would make this false. For instance, if I guess x is 5, 2 times 5 plus 1 is 11, it's not 0. So that's not the solution. So in order to find out what my answer is, I would like to rewrite this somehow so it ends up being x equals a particular number, and then hopefully that's my answer. And I have a couple of hints of what I should be doing because I want to get x by itself. Right now x is multiplied by 2 and we're adding 1. So we know how to undo those two operations. How would you undo multiplication? You would divide. How would you undo addition? You would subtract. And so those are our two likely suspects for our first step is either we should divide both sides by 2 to get rid of the 2 times x, or we should subtract 1 from both sides, since the opposite of addition is subtraction. So let's think about which of those two is the more intelligent choice. If we were to divide both sides by 2, I'm allowed to divide by 2, but I have to divide the whole side by 2. This is now something more complicated than I really wanted to get into, so I don't think this is the best choice that I could have made. So I think it might be better to use subtraction first instead. So from our initial equation, subtract 1 from both sides. So I'm just going to write it like this, but really it means I'm just taking 2x plus 1 minus 1 and 0 minus 1. So 2x plus 1 minus 1 is equal to 0 minus 1, and the negative 1, the 1 and minus 1 would cancel and give me 2x is equal to negative 1. So I've gotten rid of one of the operations. We no longer have a product and a sum, we just have a product equals a number. And again, we go through our thought process. How would we undo a product? We undo a product using division. So divide both sides by a 2 in order to cancel that 2. And we get x is equal to negative 1/2. And so if I go back to the original equation, this was a bad way to solve it. But if I look back at the original equation, this number for x should make the equation true. So let's check it out. 2 times negative 1/2 plus 1. Is that really the same as 0? So I sometimes put question mark equals if I'm not sure, or if I'm checking to make sure. 2 times negative 1/2 would be a negative 1 plus 1. And at that point I would say yes. And so yes, the answer checks out. So our answer is still x equals negative 1/2. That's the value of x that makes this equation true. But we can check our work if we wanted to. Okay, let's try another one. Solve 6x minus 3 equals 2x plus 5. Okay, so this equation has variables on both sides. But again, we still have a linear equation. The biggest power of x that I see is x to the first power. And so I have to again use my operations of multiplication, division, addition, subtraction to try and rewrite it so we have x's on one side, numbers on the other side. Eventually we want it to look like x equals one particular number. But along the way, what we're probably going to want to do is group anything that has an x on one side and anything that does not have an x on the other side. So if I look at my terms, remember polynomial notation, we call terms the things that are added or subtracted. So we have 4 terms, 2 of them have x's, and 2 of them do not. it would be really helpful if I put my terms that have x's on one side, my terms that don't have x's on the other side. So that's my strategy. What I'm going to try and do is move the guys with x's to the same side. And it wouldn't help to multiply or divide, because like if I divided by x and now there's fractions with x's involved, I don't really want to do that. I think I would rather use addition and subtraction to move things from side to side. Okay, so we have some choices here. We can either subtract 6x, and then there won't be any x's on the left, but there will be x's on the right. I'm actually not a big fan of that option, because even though the 6x's cancel, now I'm going to have a negative number in front of my x's on the right. 2 minus 6 would be negative 4. I think I would prefer to maybe put the x's on the other side. Not that, there's something sacred about the left side, but I like having positive numbers, and so for the sake of positive numbers, maybe I should move the 2 to the left instead of moving the 6 to the right. So if I subtract 2x from both sides, 6x minus 2x would be 4x minus 3, and 2x minus 2x, those go away, and so we just have the 5 on the right. And again, I'm thinking about this middle step, kind of like the last problem where we had a number times a variable equals a number. I want to make it look like that if I can, and so this is in good shape. This is where I want it to be. The negative 3 is the only part that I don't like where it is, so I should probably add 3 to both sides. And the reason I'm choosing to add is because I'm right now taking 4 times x minus 3. The opposite of subtraction would be addition. Okay, so minus 3 and plus 3 will turn into plus 0. And 5 plus 3 would be an 8. And again, we now look something like this. A number times a variable equals a number. To solve for x, we'll just have to divide both sides by the coefficient, the number in front of the x. So if I divide both sides by 4, then the 4 cancels. Notice that we could have divided by 8, but it wouldn't have been particularly helpful to do so. 4 times x equals 8 if we divide both sides by 8. 8 eighths is 1, and 4x over 8 would be 4 eighths is the same as 1/2. And then what does that tell me? Maybe I could solve it from there, but it's easier to divide by the coefficient instead of dividing by some other number. Okay, so 8 over 4 would be 2, and so our answer is x equals 2. And again, I should probably check my answer, so let me erase and try it. So we have 6 times 2 minus 3 equals 2 times 2 plus 5. So everywhere I had an x in the original equation, I'm sticking in a 2, and I put it in parentheses so I don't forget that it's 6 times 2, not 62. So let's see, we have 12 minus 3 equals 4 plus 5. 12 minus 3 is 9. Oh, I should have put my question marks, because I'm not sure if those two things are equal yet. I'm hoping they are, but I'm not sure yet. At this point, I think I am sure 9 is equal to 9, so yes. So the answer checks out. X equals 2 is the correct answer. Okay, let's do one more with some weird order of operations stuff going on. So let's try 3 parentheses x minus 4 minus 2 parentheses x plus 1 equals 7x plus 6. So again, we have variables on both sides. We would love to rewrite so that all the variables are on the same side, be it left or right, doesn't really matter. I'm a little annoyed with all these parentheses. Because I can't just subtract x's to the right if it's stuck inside a set of parentheses. What does it mean to subtract x when it's minus 2 parentheses x plus 1? Subtracting x, I don't know what that does. So, kind of like when we're dealing with fractions with rational expressions in the numerator, we want to kind of clear out these weird fractions and write in a simpler way. So I'm going to try distributing the 3 and the negative 2. So distributing 3 times x and 3 times 4, negative 4. Distributing negative 2 times x and negative 2 times 1. And I think before I go any further, I should probably combine like terms. So let me combine my x's and my constants on the left side. So make the left side, and if necessary the right side as well, as simple as possible before you start solving. Let's see, 3x minus 2x would be 1x. And negative 12 minus 2 would be negative 14. Okay, I think this is a great time to, again, mention it doesn't always have to be x's on the left. If I wanted to, I could subtract 7x from both sides, but then I would have negative numbers. I should probably try and avoid negative numbers if I can, just to make my life a little bit easier. So instead of subtracting 7x and having 1 minus 7 is a negative 6 on this side, I'm going to subtract the smaller one, the 1x, from both sides. And then we'll end up with no x's on that side. And 7 minus 1 would be 6x plus 6. And then I just have to move this number that doesn't have a variable to the other side. So put all your x's on one side, put all your not x's, all your constants on the other side. So subtract 6 from both sides. And I had this whole spiel about how we were going to be avoiding negative numbers, but there are still some negative numbers. I just have fewer of them, or I don't have to deal with a negative in front of the x. And so let's see, negative 20 is equal to 6 times x. That is being multiplied. So the way we would undo multiplication is using division. So divide both sides by 6. 6 would cancel, and x is equal to negative 20 over 6, which I think is the same as negative 10/3. If you cancel a 2. Okay, I'm not going to check the answer, but if you wanted to, you could type this into a calculator, sticking that number in for x, and x, and x, and make sure the left side gives you the same answer as the right side.